We're going to find the volume of the solid of revolution obtained by rotating the region bounded by the graph of y equal to 2x squared minus x cubed, the x-axis about the y-axis. Unlike other problems we've seen so far, finding the volumes of solid of revolution, this problem cannot be solved by using the washer method by most calculus students. Shell method is really the only way to solve this problem. If you want to use the washer method, you should try it and see how difficult that would be. But the shell method is very easy and does not require a lot of complicated steps. So first step is to find where the graph of y equal to 2x squared minus x cubed intersects the x-axis. So we take 2x squared minus x cubed, set that equal to 0. X squared times 2 minus x equals to 0. So x is 0 or 2. Let's take a value of x between 0 and 2, say x equal to 1. Plug it into the function. We find that y is 1. What's important is that it's positive. So between 0 and 2, when x is between 0 and 2, y is positive and the graph is above the x-axis. Y equals 1 is not going to be the highest value of this function on the interval 0 to 2, but we don't care what the highest value is because we'll not be using variable y to integrate. So here's what the graph looks like roughly of our region. We have the interval between 0 and 2, and between 0 and 2 the function is above the x-axis, so it has to do something like that. I'm going to select arbitrary x between 0 and 2, keep track of this vertical piece of the area. It's going to end up over here 180 degrees into the rotation, and a full 360 degree rotation yields this cylindrical shell. So the problem comes down to expressing the area of this cylindrical shell as a function of x. So recall, when we have a cylindrical shell, it looks something like this. It's a cylinder without the top and the bottom. So we have the base has radius r and the height is h. If we cut the shell along the height and unfold it, we end up with a rectangle. Looks something like this. The width of the rectangle is just the height of our shell. The length of the rectangle is the circumference of the base, which is 2 pi r, and therefore the surface area is equal to 2 pi r h. We want to express both r and h as functions of x for this problem. Recall that this is the graph of y equal to 2x squared minus x cubed. So the volume is as follows. It is 2 pi. We're taking our x's between 0 and 2. And then the radius of this cylinder is just x. So the radius of cylindrical shell is just x because it's from the y-axis over to this x. So it is x. The height is right here. It's the y-coordinate on the graph of the function, and as a function of x, that's 2x squared minus x cubed. That's the integral we must evaluate to find a volume. As I said, this is very easy. This is 2 pi times the integral from 0 to 2, 2x cubed minus x to the 4th. And so that's 2 pi times, we have x to the 4th over 4 times 2, that's 1/2 x to the 4th, minus 1/5 x to the 5th, evaluated from 0 to 2. Plugging in 0 gives us 0, so all we have to do is plug 2 in. We have 2 pi times 16 over 2 is 8, minus 32 over 5, and so this is 2 pi times 40 over 5 minus 32 over 5, or 2 pi times 8 over 5, or 16 pi divided by 5 as the final answer. You should take a look and try to solve this problem by the washer method. You'll see how difficult that will be.